Welcome everyone. This is Team 1. My name is Hossam. I was the team coordinator for this project. As you can see here, this is our project repo. You can find everything you need here from the source code, documents, simulation files, etc. You can easily navigate using the README. You can use the quick links to directly access the documentation file, backlog protocol, test protocol, and also this video that we will be uploading to YouTube shortly after. You can also find the Proteus simulation file in the Proteus clip file if you have an older version, and also the already compiled app hex file. And this is an overview to the circuit schematic that we use on Proteus here. Our team members are Ahmed Hisham, Sarah Muhammad, Alaa Hisham, and of course me. Quickly, we can review the project description. We were working on an obstacle avoidance robot. As we mentioned earlier, this robot consists of 4 wheels with 4 DC motors. At Mega 32 microcontroller, of course, 1 keypad 3x3. We're only using keypad button 1 as a start button to start the robot, keypad button 2 as a stop to immediately stop the robot, 1 button to change the default rotation direction, which we will talk about later, 1 ultrasonic sensor that is used for ranging and distance detection that detects the distance in front of our robot from the next obstacle. And finally, you have an LCD 2x16 that we show on it the current speed, direction, and the distance from the next obstacle real time. My teammates will take it from here, and I will get back to you with my role in the application testing at the end of this video. Thank you.
Hello, it's Ahmed Hisham, and I'm going to talk about what I've worked on through that project. It was the Avoidance car project. So I worked on timer driver, delay driver, PWM driver, and DC motor driver. So regarding timer driver, I'm using the 3 timers in normal mode, and I'm using the 3 timers because one is used for generating PWM signal. The second one we used for generating delays, which are non-blocking and blocking delays. And the third one is used for ICU driver, which is implemented by Hossam. So regarding testing, I didn't face any problems. I tested the timer driver by using the other drivers because all the APIs are called in the other drivers, and it all passed and was working well, except I faced a problem while using ICU. There is in ICU, it was calling an API called get elapsed time. So it supposedly returns back the elapsed time in microseconds, but the value wasn't true because it was reading from the lower byte of the counter and was ignoring the higher byte. So we fixed it, me and Hossam, and it is working well now. Regarding PWM and DC motor, the signal which is generated by using timer normal mode is generated by a non-blocking signal. So that while operating or while the DC motors are working in the application, it will not block the application from doing other tasks. So I put that in considerations not to use delays, blocking delays while using PWM driver. And regarding the delivery of the drivers, time to finish the drivers, Uh, I didn't took much more expected time. Actually, I took the same expected time to finish the drivers. The timer driver took 8 hours because it has a lot of functionalities and APIs callback functions because it's serving three other drivers. So it took a lot of time to implement it. But at the end, they are all abstracted and working well. So thank you.
Hello, my name is Sarah. I am from Team 1. The drivers that I was supposed to make is a button driver, an LCD driver, and keypad driver. As the first driver, it was expected for me to take from me 3 hours. Also, I put an expected time range like 3 hours for each. But the button driver, it was a little bit easy because I did before, so it took from me 0.5, like half an hour, and the LCD took from me 2 hours, and the keypad 1 hour. I done the testing regarding the button and the LCD as it's the same I did before, but the keypad here, I didn't use the keypad, the full keypad, I only used 2 buttons because we needed the 2 buttons only, like a start button and stop button. So that's what I did. That is my testing strategy in the keypad driver. Okay, that was my role in the project.
Hello, this is Alaa Hisham, and I'll be talking about my role in this project. As a new team, started implementing all drivers from scratch, and I was responsible for implementing the DIO and external interrupt drivers individually, as well as the application together with Hossam. As for the low-level drivers, I rewrote them from scratch to try new methods. The DIO design, implementation, and testing all went smoothly. All functions were tested individually and passed all the tests I ran on them. As for the external interrupt, design and implementation did not take long. However, during testing, I encountered some bugs. Most notably was that the external interrupt tool was firing unexpectedly, which turned out to be because the external interrupt tool could fire when the sense mode bit is changed, and was resolved by disabling the interrupt before changing the sense mode bit. Finally, for the application, Hossam and I divided it between us into functions and states. Each of us went to implement their respective parts, and then we came together again to debug the application, and then we tested it through a series of test cases that Hossam would be elaborating on. Thank you.
Hey, thanks a lot. Back again, this is Hossam. For my part, I was responsible for developing the ICU driver, which is the input capture unit that is required to be software implemented, meaning that we are not using the built-in ICU unit in the Atmega 32. I was also responsible for the ultrasonic driver, which is, as we mentioned earlier, used for ranging and distance detection by the robot to detect the distance in front of it, between it and the obstacle ahead. Okay. You can configure the ICU module using the IC_config.c file. You can choose the input capture pin. This is an enum. You have predefined options, and you can also set a callback function that return the time taken by the pin to go low again after being high, or meaning the time that pin was held high. For the ultrasonic sensor, you can configure it using the ultrasonic_config.c. You can choose the port, the trigger pin, and the echo pin. That's it for the configuration. For testing these two modules, you can find a preset function, pre-implemented function here. It's called test ultrasonic. You can also find a couple other testing functions. These all are in main.c file. You can just comment out the application, use the test ultrasonic function to test the ultrasonic and ICU modules. This function simply tests the ultrasonic continuously, gets the distance and show it on the LCD. That was it for my driver's part, and the rest I worked, as I was saying, with her on the application driver. We worked on it in parallel to save time. We're able to complete the application driver fully with bug fixing and everything in around 14 hours. It took us 2 days. Okay, the next part of this video, I'll be running the test cases we have on the test protocol sheet. See the outcome together, and I will set accordingly pass or fail status. Okay, so quick overview of our test cases. There are 7 test cases for the application itself. The first 4 is the testing the robot action in different distances for the next obstacle. Okay, from if the distance is more than 70, the robot should move with speed 30% for 5 seconds. If the distance is still more than 70, the robot will increase to 50%. The next test case, if the distance is between 30 and 70 centimeters, the robot will move with speed 30%. If the distance, like in the test case 3, and distance is between 20 and 30 centimeters, the robot will rotate in place around itself 90 degrees. Check for obstacle again and repeat the rotation if it's still between 20 and 30 degrees, 30 centimeters. As a bonus, we implemented the bonus required, which was if the robot completed 4 rotations and all the 4 directions had an obstacle with distance between 20 and 30 centimeters, the robot will stop for 3 seconds and then it will start to check again. For the last test robot action test case, if the distance is less than 20 centimeters from the obstacle ahead, the robot will move backward with speed 30%. For test case 5, 6, and 7, we are testing the start button, which should start the robot only on the welcome page and does nothing else in the other pages of the LCD. For the button 0, it's the toggle button that is used to set the preferred rotation direction by the user before the robot time out after 5 seconds and start its movement. The stop button is an immediate stop that should be tested in all these 4 test cases, as we have this written in here. So enough said, let's start with test case 1. I will get the test cases here pinned on the screen. So test case 1, the robot action if the distance is more than 70. Quickly pressing start, you can set the default rotation here for 5 seconds. After the 5 seconds, it will time out. If you click stop, it will just revert back. If you click start again, it should remember that we want it left. That's an extra, so it does remember. You can also change it again, so choose left and wait for the 5 seconds timeout. Starting direction left, 2 seconds, and then it will start moving. So distance is 38, which means that more than 70 means that after 5 seconds it should increase the speed to 50%. We will wait. So here 50% after 5 seconds. If we go lower than 70, which is this case too, between 30 and 70, the robot immediately decreased to 30% and maintained a stable speed. So test case 1 and 2 matches the expected results. Test case 3, which is a distance between 20 and 30, the robot should rotate. So going down to distance lower than 30 but higher than 20, robot started rotation. To rotate for 4 times, as you can see, it blinks to 0, and now after 4 blinks it stops for 3 seconds. This is the bonus. It will start again rotation. So this is 1, 2, 3, and this is last one. It will stop. So this is the bonus requirement. This also matches. And for the distance less than 20, gonna go lower than 20. It's moving backward with speed 30%. It will keep moving until the distance changed. If we click stop in here, it immediately stops. We start again. We'll quickly test the stop button in different cases. So stop button in less than 20 works. We will test it in the 20 to 30 range. So going up to 25, we will click stop. Here we go. Okay, so we might have just ran into a minor lag issue with the stop button in here. That was just fixed, and it will be pushed to the repo before the release. So let's retry. So pressing start, changing the default to left, and starting. Here the robot is rotating. So this is the second time. Pressing stop immediately kicks out. We will now try to press stop while the robot is waiting idle for 3 seconds after completing 4 rotations. So this is the first, second, third, and fourth. Should stop. Okay, pressing stop immediately goes out. So this issue was fixed. For the next test case, this was a rotation 30 to 70 distance. You will test the stop button. So 30 to 70, the robot is moving with speed 30%, direction forward. Pressing stop immediately stops. So we might also double check the more than 70 real quick. Okay, starting direction, increasing the obstacle distance to more than 70. Okay, we're gonna wait till 50%, and next time we'll stop at the 30. Okay, 5 seconds passed, 50% speed, stop, immediately turns off. For the last stop test is during the first 5 seconds while the robot is moving with 30%. So pressing stop, it turns off. So that was our testing for the whole application. I hope you enjoyed it, and sorry for being Sorry for the bug. It will be pushed immediately now before releasing the application. Thanks for listening.